Good morning to all. Thank you organizers for giving this opportunity. Now, my topic here it is approach to maximize recovery, treatment and recycle and wastewater. To tell you this is, we are technological company. We provide the solution in a water, wastewater, desalination, etc. from concept to commissioning and also PMCs. And we do some of the special projects based on the request of the clients. And also we provide the training on training for engineering customization and bringing down the times, engineering time, etc. Okay, now coming quickly on the background of this particular thing. This development, it has taken quite a few years. We are working on this particular product development. And we do many of the product development in the wastewater. Last year I presented on the blower laceration system, and this year we are giving this, and next year something else will come. And this is mainly the background of this product was today everybody we have talked enough on what is the problem and why this is needed and etc. So you know all these things. The main thing it is the water conservation. It is the challenge today. And also, sustainable development of any community needs the proper balance of water and wastewater products and recycle and also the energy consumption. Today, water, which is the best described as one for all and all for one. There is nothing different in that. So effective conservation is the need. Now we have talked about, many of the people we have talked about how to consume and all those things. But I come from the other end, that is the end users. Let us look at this agriculture. Yes, that is the maximum consumer of the water. But let us look at who is the maximum contributor to the pollution. That is industrial sector. So industrial sector, how the energy it is, you can see that. That is, of course, the engineering and consultants. This is we are seeing the many. This is multi-story buildings, and they are using so much of producing so much of wastewater, and also they are in a way they are recycling it back. So you can see how much it is being used and how much of this percentage of the water it is discharged. Just it is letting it out. So that is both the things I am producing it or providing to you all that. So it is whether engineering, pulp and papers, textiles, steel, sugar, fertilizer, pharmacy, food, and all other sectors. So it has been a long deliberation, and we thought of how to come out with the new product. And then we have analyzed what are the particular challenges in all these particular things like STP or IWTP, desalination, and food and beverages industries. That is everywhere, everyone is producing the wastewater, and at the end they say that they have put the complete this wastewater treatment plant and it is complying to the pollution control board norms, and then they are letting it out the water. But there is also a small component that is related to the final concentrate or the sludge or disposal of the water. This particular thing, it is very few people are addressing that. So now in the SPP there is an n number of problems. That is, it needs a large area today, land value with the prime values. It also, that is, one is the costliest, and also it is a very prime commodity. And all the STP needs the extensive pre and post treatments, sludge disposal, operating cost. Today, in any of this STP in our country, it is not working because people are not willing to work in the STP plant. This is the fact. We have to accept that. The reason is nobody goes to this STP plant and stand on this smelly area and treat that particular and work on that particular plant to give you the best water. What is really happening at the STP plant is nobody goes near to the sludge treatment area at all. If you visit I have visited a number of STP plants. Everywhere it is not working. Either some or the other problem, but predominantly many of the sludge treatment area or the filter press, they are purchased and installed, and it is a brand new. Because people don't want to go there, because once it is sludge press, it is water is spilled out, and that is the waste, and nobody wanted to touch it because of it is a mindset. That these are all the problems it is inherent with our STP plant, and we have to come out of that. Okay, so next is coming to the industrial wastewater. Of course, it is industrial wastewater. It consists of even a very hard COD and BOD to remove, and that is also there. If there some of the industries they produce some of the salts, and it's again it becomes a concentrate reject, concentrate disposal, and all those things. Because of this norm says above 2000 TDS, water cannot be rejected, sent to this one. They cannot send it out, so it has to be below that. So that is all those compliance issues it is there. Again, operation and maintenance cost. And to achieve that particular this one norm, there is a steps involved is too much. Coming to the desal, again, I don't know whether some of the people are maybe knowing it. In Middle East countries, yes, they are using the desalination plants predominantly for water, drinking water and all. Now, in last 10 years, the TDS of the seawater in the Middle East, it has already increased by 10%. Because I'm working in that area for this desalination at many times. Now, since long. So that's why this particular thing, it is a very longer effect. So this one we have to look at now. We are talking about the future generation. We have to address these things now. Now, coming to this, again, food and beverages, same issues. So we thought we have to come out with some other things. Of course, this is the one of the token, that one technology, many solutions. That was the captions we have put in. How it works is, it works on low temperature. It is called low temperature zero discharge plant. It is a combination of vacuum boiling, adsorption, condensation, and refrigeration cycle. So in a vacuum boiling, we boil the water at the room temperature, and adsorption, it absorbs the vapor generated, and it is being heated up at 70 degree, 65 to 70 degree to relieve that particular absorbed material and condensate to take the complete water, this pure, ultra pure water out. And also, we are using the refrigeration cycle. It is mainly for taking out when there is a high salt content is there, it has to be removed. Then we use the refrigeration cycle. These are all the technologies. It is without microphone, I think I am audible. Yes. Yeah. So, refrigeration cycle, we are using it mainly to take out the salt content. These are the technologies. It is being used in one or the other industries earlier in India or in the globe, but it was not put together. That is what we have done it. Now, if there is too much of salt, then what we do? We have used the eutectic technology. Eutectic point, it is there for every element, every solution. That is a triple point, which is having the saturated salt, water, and ice all together. So in that particular thing, we precipitate and we separate the salt from the water, and we get the good water. To give you the complete small this one, the schematic arrangement, this is how it is. It works on a batch cycle, and bottom is the evaporator, which works on the vacuum boiling, and remaining things it is the cyclic method. One is absorbing, another one is absorbing, and at the top that is which condenses the water, and you are taking the pure water out, and all these non-condensing gases it will be purged out. Here again, we have gone one step ahead. Of course, there is energy is needed for heating and cooling. What we have done is, those are the waste energy in most of the industries it is available. Either the heat emanating from the ACs, air conditioner, or the power plant, or even the solar this one, it can be used to get those things, required energy for that. Then, of course, then there is a sludge. Of course, here also there is a sludge is generated. Now, what we do, we have used the low temperature dryers. Again, it works on the same refrigeration cycle. We take this sludge, we draw the sludge, and we will be drying it, and we are giving it at 96% dry sludge, which is in the form of powder or anything that can be used in any kind of other, either fertilizer or in the brick making or many other issues, many other opportunities are there. There is also two things. One is if there is a high salt content. Another one is municipal, that is which is more on TSS side. So there is two types of the things which we will be using. We have done the testing on one is for this seawater, that is with the 35,000 milligrams per liters of the TDS, and another one it was done with the municipal wastewater. So we are getting the very good results. So this result, it is, you can see that produced product water, which is the temperature is always less than 30 degree and TDS is less than 10 ppm. Most of the times we have achieved, we are getting the TDS less than 5 ppm. Okay, 10 is some point we have got it. So this is the simulation conditions, and the different parameters are there. Now, it is as I told you, it is a batch process which we are talking about. In this particular case, there is a threshold limit on the concentrate, that is 160,000 milligrams per liter. So it is you can correlate this one with the influent water TDS. That is the recovery you will be getting it. So this is a very phenomenal recovery. Typically, in case of the sewage and all those things, you will get a ultra pure water plus 90+%. Whereas in the seawater, you will be getting a recovery of 80+%. This is a very phenomenal. And in the present condition, even with the membrane, you are not getting more than 40% in case of the seawater.
Please confirm now.
Yes, yes. I'm giving you just a sample, this one energy consumption, which is directly related to the TDS and all, and power consumption. It is also it is related to that. And we have the modules 10 KLD, 50 KLD, 100 KLD. It can be used. And this is some of the comparisons. It can be used in these are all the industries where you can apply this, and these are all the application part. And this is technology which is very cheap because it doesn't need any high or the very vigorous treatment process, and it is very simple. So it has a very capex and opex advantages. And these are all the main advantages here, and few snapshots of that. And thank you.
Thank you very much. Now for the last presentation in the session, we invite Mr. Chaitanya.
We are talking about, in this particular case, there is a threshold limit on the concentrate, that is 160,000 milligrams per liter. So it is you can correlate this one with the influent water TDS. That is the recovery you will be getting it. So this is a very phenomenal recovery. Typically, in case of the sewage and all those things, you will get a ultra pure water plus 90+%. Whereas in the seawater, you will be getting a recovery of 80+%. This is a very phenomenal. And in the present condition, even with the membrane, you are not getting more than 40% in case of the seawater.
Please confirm now.
Yes, yes. I'm giving you just a sample, this one energy consumption, which is directly related to the TDS and all, and power consumption. It is also it is related to that. And we have the modules 10 KLD, 50 KLD, 100 KLD. It can be used. And this is some of the comparisons. It can be used in these are all the industries where you can apply this, and these are all the application part. And this is technology which is very cheap because it doesn't need any high or the very vigorous treatment process, and it is very simple. So it has a very capex and opex advantages. And these are the main advantages here, and few snapshots of that. And thank you.